You can lower that down.
Is that fine? I guess. That's what it's
Oh, yeah. I'm going to speak, so I'll be sitting right here.
Oh, you'll be sitting?
Yeah, I'll be sitting here, so you can take that chair. So, good afternoon, everyone. We're going to go ahead and get started with SDLE Tea Time. So, today will be our first day of a 6-week installment that we'll be giving. Today we'll be learning about the Linux command line and some Linux background and Git. So to start, I'm going to pull up our flyer and zoom in. So what Tea Time is, we are the Solar Durability and Lifetime Extension Center at Case Western Reserve University, and we do a lot of things involving data science and data analytics, and we're giving a 6-week series with 3 presentations each week to give a short introduction to a lot of different topics in the field of data science. So we'll start with some introductory things, and then as the 6 weeks move forward, we'll get into more detailed, specific things. So to get started, we'll start with the Linux command line. And it's always good when you're learning about something just to go to the Wikipedia page and see what it is. So if we open the Linux wiki page, we can see just some background about Linux if you want to read in detail about it. It is an operating system, Control plus to make it bigger. So it's a Unix-like computer operating system. It was developed in 1991 by Linus Torvalds. If we go to his page, you can see this guy. And it is quite a popular operating system as well. If we open another page, Linux is actually the operating system behind Android, and some of the Mac things were also developed off of this same base. So you can see, looking at these percentages, that since Android's based upon Linux, that it's actually the most distributed operating system worldwide. And so a lot of the things that we do with our group are based upon this Linux framework. And if you wanted to, if you're a Mac user and you'd like to get your Mac to perform more like a standard Linux machine, you would need to look at some of these additions to install, one being Homebrew, which is described as the missing package manager for Mac OS. So here's just a short command that you could use after we learn how to use the Linux command line to install Homebrew, and that'll get your Mac up and running better. And Xports as well. It solves some compatibility issues with Macs, so that when you're using different software packages that weren't developed specifically for Mac, but they were for Linux, that your Mac will be able to use those. And then for Windows PCs, there's some specific things that you might want to install. For example, R tools. We use a lot of R analytics in our lab. And to get R running on your Mac or PC, you might need to install that. So now moving on to the command line interface. What this is, it effectively allows you to interact with the computer the same way you do with a mouse. This is what the command line might look like. For example, here I've just typed hello in an image. To open the command line on Linux, you can search and open console, and that will generally get you there. On a Mac, you do a similar thing. You'd search terminal, and it would open. On Windows, and we might suggest maybe getting a new computer, but to open a usable command line interface on Windows, you could install Git Bash, which I'll be using today because I'm on a Windows PC. You can go to the link I've included here, and the installation is pretty straightforward. And the way that you generally interact with the computer at the command line is you use commands. They generally follow this sort of framework, in that in red we'll have some command, which is usually 1, 2, 3, or 4 letters, a short set of letters. then you have some arguments that the command will operate on, and then there are some options that you can include in the end. So now we'll be going to a command line demo just to show the types of things we can do at the command line on your PC. And before I go to the demo, I'll just show a link to a reference sheet. There are many things that you can do at the command line, from moving around in directories, doing file operations, all sorts of things. So this is just useful to see if you ever want to know all of the many things, so you don't need to memorize them. There's always sort of a cheat sheet there. Okay. So I'm going to open up my command line. I'll maximize it. Hopefully, is this big enough for everyone to see? Maybe
Could be
bigger?
a little bit bigger.
Yeah, okay, so.
In the upper left corner, or Control Plus, I think also.
Yeah, I usually just go to Options, and you can go into Text. So this is for people using Git Bash. You could do this, and then you can go into Text and select to change the font size. I'll do a little bit bigger. Okay. So I sort of equate getting started at the command line to being sort of thrown in a forest and you don't know where you are or where you're going. So the first thing you want to do is find out where you are. And to do that, you can type PWD, which stands for Present Working Directory. So when I type in Present Working Directory, PWD, and get Enter, the command line returns a response to me. It says that I am in this place, H drive git, then SDLE p time. So the working directory is basically equivalent to the folder in a file explorer that you would have open, for example, in Windows. Next, what you would do is to see what's inside the location that you're in currently. So that would be done with an ls command, which stands for list. So I can see that there are some files in my current working directory. Also, you could modify, put an option at the end, a -A. What that would do is show you all files. So there are some files and directories that will be hidden. You can see that these, in the output, we have things that have different colors, and the things in white would be files, for example, and in blue we have directories or folders. And then we have these two special places that's represented by a dot and two dots, and these are important to sort of understand. A single dot representing where we are currently in our working directory, and then two dots being one directory above or backwards from where we are now. So that would be the equivalent of looking here. So this whole directory here is what our dot would represent. And then two dots would be one step backwards, so that would be just the git. We can also use the command line to make changes within our file system and move around. So for example, if I wanted to move up one level, I could use the cd command, which is change directory. So this is going to allow me to move around in the file system. And if I give that the place that I want to move to, which would be the two dots or two periods, we would move back. So now we can see that our command line is giving us h:git. So now we are one step above where we were. We can also make new directories. So if I go back one more level to just my H drive, I can use the command mkdir to create a new directory, and I can give this just a name like test. And so now I didn't get any return, but if I wanted to see the result of that, I could give a list and then look for the directory I just created. So my test is now here. I think one more specific place to understand, there is this character, the tilde. This represents your home directory. This is like your personal place with your personal account where you can store your files. So if I change directory to this tilde. I think I'm running out of space here. If you ever run out of space, you can type clear, and that will clear your screen. So now if I look, I'm inside of tilde here. This would be my home directory. So if I go pwd, it took me to my C drive users and then my personal account DAG109. So I can look here, and there's some files and directories and folders there. And I also have already made a test directory, so if I change directories into test, you can look what's here. So I have a test file here. So one of the common things that one might do in just a general file system, another thing is copying files. So there's a cp command, which allows you to copy things from one place to another. So if I want to move my test file up one level in my tree, I can copy the test file, that would be pointing to the file that I want to move, and then give it the location of where I want it to end up, and I could move it up one level with the CP. And then go back one level with change directory and look at the result, and might need to just can't see the bottom of the screen. Yep, so then my test file is now inside of the directory and one level up because I copied it. Let's say I didn't want to do that for some reason, and now I want to delete the file that I moved or copied. I could use the rm command, which stands for remove, and then give it the file. And then the file will be gone. If I look for it again, it's no longer there. So that's just an example of some of the things that we can do with Linux at the command line. And then we can switch gears to Git and looking at some things that we can do with Git. So what Git is it's a version control system, which is, these are used to manage changes to a file or a set of files. And with the concept that we want to be able to recover previous versions of our files or track the changes that we make over time. So some situations in which this might be useful is if we are, making an image in which we're going to make iterations or make changes over time, or we have people working together on some text editing like writing a paper, or if we're developing code or scripts, which is something that we do a lot in our group. So there are 3 types of version control that we're going to look at. And the first being local version control, the second being centralized version control, and the third being distributed version control. And we're going to look at the ways in which these things are similar and different and how they build upon one another. So starting with local version control, this would be like, let's say our version database is just a PC, and we have a file that we're looking at. So we can just store different versions of our files locally, and we could differentiate them with different file names, maybe put a date on the end, or put them even in different folders. So it's pretty easy to see the dangers of using a version control system like this, is that it's easy to accidentally overwrite one version of the file, or you could just delete the whole thing and not have any sort of backup. So to improve upon that, we could move to central version control systems, which is where we save the different versions of the file in a central server. So now we've sort of gained the benefit. Now we can collaborate, so we could have 2 users, which could be computer A and computer B, that both have access to this database. They could both pull their versions of the files and work on them separately. Well, one of the hazards here is that this whole thing is dependent upon this central server. So for any reason, if the server goes down or crashes, or if there's a loss of data, there's no way to get your data or information back from that. So to solve both of those problems, we go to distributed version control systems. which is where the different versions of the files are saved in a repository. And here, the difference is that when a copy is pulled down to a computer from the central location, you get all of the version history along with just the file that you're interested in. So let's say that this server computer here were to fail, that'd be okay because each copy is contains a complete history of the files and all the changes that were made. So some examples of this are Git, which we're going to learn about today and which we use a lot. There's also Mercurial, Bazaar, and Darks. So the fundamental concepts of Git can be understood by first looking at what others do. So others, they basically house the files that we're interested in, and then they look at them as just the files and a list of the changes that are made over time. So Git differs from this in that it effectively looks at a snapshot of the entire file system at each point in time that it's pointing to. So we can see here, let's say we have version 1 being a set of 3 files that we're looking at. And as we go along through time, we might make some changes to one file or 2 of the files and not the others. What Git will do is that it will only take snapshots. It will take a snapshot of the whole file system, but only looking at the specific changes that were made. These are the ones that are not outlined. So when the file remains the same, it simply just travels along until a change is made. And a good thing about Git is that it generally only adds changes, so you don't have to worry about messing anything up. Really, it's not gonna, if you delete something, you can always go back to that previous version. And Git tracks all of these changes via a SHA-1 hash checksumming, which is this 40 character alphanumeric here, which is calculated based on the file or the directory in a Git repository. So every time a change is made inside of that repository, the 40-digit alphanumeric is recalculated, and if there's a difference there, it'll be tracked by the Git repository. So this is an explanation of the general workflow of how you use Git. So first, the repository is stored in a .git directory. This will be the central location. For us, this is Bitbucket, which we will get to see later. And then you have a working directory, which is one local copy or checkout, as Git users call it, of the repository. And so this would be like your PC, the local version. And then there is a staging area, which stores information that will go into the next commit, and all of the changes that you make are sent as a commit. So you would generally be working, modifying files in your directory, then you will commit these changes to the Git repository, and then later on you could then pull them back down, or someone else could pull them back down. Another concept to understand about Git is branches. So currently we've been talking about effectively having one set of changes over time that go through linearly. So we can consider that being this master branch that we call it. What branching allows us to do, it allows us to develop simultaneous features or parallel code without fear of ruining everything else that we've done. So we could branch off from our main linear chain of commits here and make a small feature, or we can make a large feature which might have a series of multiple commits as well that we want to later put back into the main branch. And when we want to put those files back in, that would be called merging. So there are 2 types of merging that we're going to look at. One being a fast forward merge, which is shown here. So let's say we have our master branch, which contains some changes that we've made over time. And then we want to go and develop a feature. So we make a branch, and we might have 2 sets of changes that define this feature that we want to bring back to our main branch. So when we do a fast forward merge, there's no deviation here, so all that we need to do is merge, and the master branch simply catches up in time to the feature or the side branch that we made. The other type of merging is a 3-way merge. This occurs when the branches have diverged. So let's say after we'd started working on our separate branch, some other feature, that we then made some set of changes to our original master branch. So we would need to, or Git would use the 2 branch tips and then their common ancestor, which would be here, or here actually, to merge them back together in time, so it would bring all the information back together and unite all the changes. So to install Git, there's a few different sets here. Generally, if we look in the links, they all go about the same way. It's easiest, for Linux and Unix, we can install Git just with a set of commands at the command line. You can see here. On OS X, it's pretty similar, but you can also download it just as a package here, and it will start automatically if you click. And for Windows, you get the standard Windows download button and install like normal. And some resources if you want to know more about Git and how to use it and some of the more in-depth things that I didn't cover today. There's a comprehensive book that you can link to here. I've actually taken a lot of the things in these slides come from this book. You can go from basics to branching to using Git on a server. All of the different types of tools and functionalities that Git has are included in this book. If you need more of a visual guide, here's a Git visual guide. If you didn't understand some of the images you've seen here, this is a good link that will walk you through it in depth and show you how things flow. And then for a hands-on tutorial, if you want something to walk you through step by step, there at Atlassian, there is a sort of 30-minute tutorial here that you can go through if you've already installed Git. So now we can look at Git at the command line. So I will change directories back to my H drive. And I have a folder already set up to hold a lot of my Git repositories. Since I work a lot with Git repositories, you can see I have a number of repositories already pulled down. But I'm going to go to bitbucket.org. And I'm already logged in here. So once you log in, go to Bitbucket and sign up and get an account. You can log in, and you probably won't have any repositories when you first log in, I'm sure. But you can see I have repositories here. If I go inside of one of them, like the tea time repository, this is a public repository, you can see that there are the source, which is actually a list of everything inside of the repository. At the bottom there's a README, which is a file that explains what the purpose of the repository is and sort of gives you a description of what the people using it are working on. For example, I'm going to show you all how to create a repository if you don't have any, so you can go to the plus on the side and you can click create a new repository. So when you create a new repository, you can change the ownership. So there are teams. We have a team here at Case Western Reserve University in which we collaborate on lots of things together. But when you're just getting started, it will most likely just be you. You can give the repository a name. So I'm just going to call this test repo. Make this bigger. And then I'm going to make sure I click that this is a Git repository. I can click create, and then I have an empty repository. So now if I wanted to pull this repository down to my PC, I could take this HTTPS text and just copy it, then go back to my command line, and then the command you use to bring the repository to your PC is git clone, and then paste the text that you got from Bitbucket. And you get that, and it will tell you that it's cloning into this repo, which means it's pulling it down from Bitbucket to your PC. So it tells me that I've appeared to clone an empty repository because I don't have any files in there currently. So if I want to put some files in there, I can go steal one. So I can change directories back to my home and give a list. So I have a file that is snowwhite.txt, and if I want to look inside of a file and see what its contents are, useful command for that would be cat. And if I take a look inside of snowwhite.txt, so basically this looks like the whole Snow White story. And then if I want to move that file into my Git repository, I can use the mv command for move. So if I go give it, I want to move the snowwhite.txt to my H drive, Git, I think it's test repo. Then I can go back to the H drive, to the test repo. And give a list. And now I can see my Snow White text file is there. And now since we're in a Git repository, there's this master here, so that tells us that we're on the master branch of our Git repository. If you remember back to the schematic that I showed earlier with the branches, this is going to be the main set of changes or line of commits for the repository. So now that I've made some changes, if I want to then send those changes back to Bitbucket, where the repository is hosted, I use the command git add, and we usually put --all. What --all does is an option. It takes all of the changes that have been made and commits them instead of just one specific change. So I get a warning message there, but that doesn't really affect what's happening. After you add the changes, which stages them, we then want to commit them. So this command is git commit with the option -m. The -m stands for message. It's always handy to put a message on your commit so that the people also working in the repository know what those changes are, or if you're going back and looking at what changes you've made, you can understand what you actually did. Otherwise, it would just be represented by the 40-digit alphanumeric, which doesn't have much meaning. So I'll call this adding Snow White. So it shows me that there's one file change in the repository, 157 insertions. Those are probably the 157 lines of text inside of the Snow White file. And then to push those changes, the command is git push. So usually when you do git push, there will be a box that pops up that asks you for your Bitbucket credentials, but since I've already used it, it doesn't ask me for my credentials. And then to look at those changes, if we minimize our console, we should be able to refresh. And now we can see that there's one commit that's been added the Snow White, and if we go to source, we can see that now we have the Snow White text file in the repo. So now to show how branching works, if I type git branch as a command, it shows me that there's only one branch in my repository, the master branch. So to create other branches, the command is git checkout and then the branch name, or git branch and then the name of the branch. So let's say I'm going to make another branch called test. So that should have created the branch, and if I go git branch again, now I have a master branch and a test branch. And then to switch branches, the command is git checkout test. And now you can see that I'm no longer on the master branch, but now I'm on the test branch. So now, let's say I make some modifications to the repository. For example, if I remove the snowwhite.txt file, and then I'm gonna stage those changes and send those up to Bitbucket. Let's see what happens if we want to then merge afterwards. So git commit. We removed the snowwhite file. So now we can see that there's the same number of deletions as we had additions before. I push these changes. It won't let me because the current branch has no upstream that points to Bitbucket. So to do that, it gives us the proper command that we need to use to set the upstream before we can push. And then after we set the upstream and give it the push command, it will then send our changes to Bitbucket. And then, now we have sort of, if you think back to the situations of merging before, this should be a fast forward merge because we've only created a linear difference between the master branch and then our side branch. So if I switch back to our master branch, it tells me that everything's up to date because there's been no changes in master. Now I want to merge the changes that I've made on my test branch into my master branch. And to do that, I use git merge test. And then it tells me that I did a fast forward merge and that those deletions are now added to the master branch. And that's sort of how merging works. And the last thing that we'll look at is, if we go back to overview, actually my home. If we go back to the T-time repo, everyone that's following along with us will need to pull this repository to get the updates, and you can get the contents that are presented at each of the T-times from the repository. We'll be adding in the files and updating them day by day. So you'll want to do basically what we did before. Take the HTTPS here and copy it. And go change directories to wherever you're storing your Git repositories. Do a git clone of that T-time repository. And mine already exists and is not empty, so it won't pull it down. But for you, that would allow you to pull down the T-time repository and look at what's inside. If we change directories to the T-time, we can take a look at what's inside the list. So the way that this is set up is that we have some general files like the table of contents that explain what's going to go on from week to week. We have some assistance files for Git branching commands, fixing problems with your repos. Then we have a folder or directory for the flyer, which outlines everything. We have directories from previous years. We actually have already given a lot of presentations last year if you want to go ahead and read ahead or catch up on things. We have some readings on data science that we can look at, and some topics contains the actual presentations and slides that are shown from week to week. So first we can just look into previous years and list. So we only have one previous year, that's 2016. Do a list. And I believe it's under topics. We can see that we had 8 weeks with all of our different topics. If you want to read about R, Git, Python, or any modeling, you can look at those previous workshops that we gave. And you can actually chain this double dot to go backwards multiple levels, back to the top. Then going into topics, or actually we'll go into readings just to see what's there. So under readings, we have two directories. One is textbooks and cheat sheets. Cheat sheets are things like lists of command line commands and get commands and things of the sort. Textbooks are things about you can read on doing data science or learning R, learning Python, any of the scripting languages that we'll present on. And there's also some papers on research that we do in our lab that use these types of data science applications. And finally, under current topics, if we go to just the topics, we can see that there's an outline of our 6 weeks of tea time here. Right now we're in week 1, Intro to Data Science. If we do a list there, you can see that there's this Linux Git presentation, which are the slides that I presented on today. With that, going back to our slides, I think I've given the link here to the Bitbucket, the Tea Time Bitbucket. This is a public repository, so anyone out there should be able to go to this and pull the repository. And then for tomorrow's presentation, we'll be learning about R and RStudio. So if you want to go ahead and install those to be prepared, you can take these links. You'll need to install them in this order. First, install R. If I go full screen, I should be able to click. So here, all the different versions of R. It's most useful just to install the most updated version because packages and things get outdated quickly. And then you'll want to install RStudio, which is the sort of user interface for using R in a more easy to learn environment. And with that, I'll take any questions that anyone has.
Can Saldas comment that these are being live streamed on Twitter, so that therefore you can just watch them from your desk even, and then there'll be those videos of all this will be then made into a YouTube playlist that we have for all the sessions. So YouTube you can watch after the fact, but you can watch them live each day on Twitter.
Message first.
I can't find the tea time repo.
You can't access the repo.
Uh-huh.
If you take the link, it doesn't work for you.
So yeah, maybe I'm definitely doing something wrong.
Okay.
Maybe we'll talk after.
What I
You
can
just go to Bitbucket and search on SDLE and tea time. It comes up.
So if I go to bitbucket.org, not logged in as me, then
You have search in the upper right.
I don't think there's a search. So we probably have to make an account before we can see it. Or
You type in something random and go to an error, then it'll give you a search button.
Yeah.
on login?
Up on in the URL.
On the URL.
With Bitbucket as the prefix. So Bitbucket
yeah.
/ something random.
All right. So yeah. So if you search something random on after a slash on Bitbucket, you can search for a repository. If we look for, I think it's 17 SDLE.
Yeah, you can do Bitbucket SDLE tea time. And
So it should come up if you search 17 SDLE tea time. And then I'm not logged in as anyone, but I can still see all the things inside. Arash.
Yeah. So I have a question that those two branches are like modifying a file, a section of a file that are same. So if they want to push their changes, if you want to merge
So if you have two branches and you're talking about ASCII files, so it can read the contents, then everything that is got a carriage return on the end, so every sentence will be a unique object, and if someone edits one sentence, a different person edits another sentence, those will merge correctly without any conflicts. If you were writing a whole paragraph before a carriage return, and you both edited in that paragraph, then there'll be a merge conflict, and it will mark out with greater than head, and put both of your contents in. And then you can go through as a human being and resolve the merge conflict manually.
Yeah. There are also some merge conflict tools when they get to be very complex that allow you to sort through the different conflicting lines and then pick which version of them you want to accept.
Cool.
Yeah,
Why
right.
use Bitbucket for Bitbucket instead of GitHub? Like, what's the difference between like?
There's no substantive difference. So GitHub is the bigger one. It's more successful, quote unquote. All that kind of stuff. It has more users, but GitHub doesn't. Bitbucket gives EDU users unlimited private repositories. GitHub does not. So after 5 private repositories on GitHub, they want you to become a paying customer, which is okay. You know, they can choose to do that. But that's why we end up using Bitbucket. But because GitHub has a larger audience, then if you have open repositories, such as data science projects you've done and you're looking for a job, then you should also have a GitHub account, and you should put your open repositories up there so that people who are wanting to see your skills can check things out.
What's the difference between git fetch and git pull request?
Between a Git session, what word did you use?
Git fetch versus git pull.
A Git which?
Yeah.
Git fetch, I think it's overwrites whatever you have in the current directory, and it will just push everything, irrespective of whatever you have in the current location. So I think that's the
Actually just looked it up, and git pull uses git fetch, but also then merges it to what you currently have.
Okay. So you could do a fetch to grab the changes without merging them, but then a git pull does both at once. Any other questions?
So tomorrow is an introduction to R, Thursday is an introduction to Python, and then we're off and running. And so people who don't know any R might want to look at last year's R sessions, which was a week long, to get some introduction to it.
Thank you.